Have you ever wondered what truly happens inside your computer when you click a button or open an application? Today we're taking a visual journey into the heart of your computer, the Central Processing Unit or CPU, using this fantastic simulator. First up, we have the instruction register or IR. Think of this as the CPU's immediate to-do list. It holds the very next instruction the CPU needs to execute. Right now it's showing HLT for halt, meaning the program is about to stop. Next, the control unit and decoder. This is the CPU's central manager. It takes the instruction from the IR, understands what needs to be done, and then sends out the necessary control signals to orchestrate all other parts of the CPU. Meet the program counter or PC. This crucial component keeps track of where we are in our program by storing the memory address of the next instruction. Notice it increments by +2, ready for the next instruction to be fetched. The ALU or arithmetic logic unit is where all the heavy lifting happens. This is the CPU's calculator, performing all the arithmetic operations like addition shown here and logical operations like comparisons. It's the muscle of the CPU. Then we have the accumulator or ACC, a special register that temporarily holds the results of those ALU calculations or data loaded from memory. And beside it, the status word or STAW, which contains flags like 0 or negative, giving us feedback about the last operation's outcome. The multiplexer or MX acts like a traffic controller. It selects one of many incoming data signals based on instructions from the control unit, ensuring data flows precisely where it needs to go within the CPU. Now you might be wondering, how does the code we write in high-level languages like C or C++ actually get here into the RAM as these LOD and ADD instructions? It's all thanks to a process called compilation. For example, a simple C++ statement like int d equals sin x plus e, where x is 8 and v is 5, gets translated by the compiler into fundamental assembly instructions like our LOD x to load the value of x, ADD y to add the value of y, and STOZ to store the result back into z. This is the crucial step that bridges human readable code to machine executable instructions. And finally, the RAM or random access memory. This is your computer's short-term memory where instructions and data are stored for quick access by the CPU. You can see various instructions like load, add, store, and even our halt instruction along with data values for x, y, and z. Let's trace a specific set of instructions, LODX, ADYNs to z. Our PC starts at address 0, pointing to LODX. The CPU fetches this instruction, places it in the IR, and the PC increments to 2. The control unit decodes LODX, the address of x is sent to RAM, and the value 8 is loaded into our accumulator. Next, the PC points to address 2, fetching ADDY. The control unit decodes this, the ALU prepares for addition. The value of y, which is 5, is fetched. The ALU takes the current ACC value of 8 and adds 5 to it. The result, 13, is placed back into the accumulator. Finally, the PC points to address 4, fetching STOZ. The control unit decodes this. The CPU sends the address of z to RAM, and the current accumulator value of 13 is written to memory location z, updating z's value. This sequence is part of the fetch-decode-execute cycle. Fetch. The PC sends an address to RAM. Instruction returns to IR. Decode. Control unit deciphers the instruction. Execute. The LLU performs the operation. This cycle repeats millions of times a second, bringing your computer to life. And there you have it, a deeper glimpse into the incredible work happening inside your computer CPU. It's a complex yet fascinating dance of components, all working in harmony to execute your commands. Thank you for watching. If you found this helpful, please hit the like button and subscribe for more tech insights. Don't forget to ring the notification bell.